Hello everyone, we are going to start reviewing for our test. We're pretty much putting all this solving into some word problems and then just can you solve a 2 and 3 variable system? Which really, you can't do a 3 variable system if you can't do 2 variable systems. So, when we solve a 3 variable system, we first need to realize that being organized is very important. So I like to label my lines, and then first thing, we have to decide what variable can I eliminate, hopefully in an easy way. And I kind of noticed right there, if I add those together, z's will go away. But you also want to make sure that you have another way to do it. So if you only can find one strategy, that might not be your best play. I think it will work here because I can double this line, and then that'll be positive 4, and then it'll cancel. So I have two ways I feel pretty good about. The first way that I'll do is lines 2 and 3, and I'll just go ahead and add those together. So when I do lines 2 and 3, I get 1 plus 3 is 4x, negative 5 and negative 2 make negative 7y. That goes away, and 19 plus 14 is 33. I call that my A equation. Now, like I said, I want this to be 4, so it cancels out with negative 4, but you can't just change one number. You have to double all of line 1. So I'm going to take line 1, and I'm going to double it. Oh, wait, I don't need to write that. I'll just write it right here. 2 times line 1. It's really important that you keep track of what you have done, because if you make a mistake and you don't know what you did, there's no chance at fixing it. You have to just start over, which is a bummer. So if you keep track, 2 times 4, 8x, 2 times negative 6, negative 12y, 2 times 2, 4z, and 2 times 28 is 56. So if I go back and look at it and like, oh, I put 6 instead of 12, at least I know I was supposed to double it. And then I'll keep line 3 the same way it was, just because that'll cancel out the z's, which is what I'm looking to do. So when I now add these two together, I have 8 plus 3 is 11x, and negative 12 and negative 2 make negative 14y, z goes away, and 56 and 19 is 75. That will be my line B. So we eliminated the same variable 2 times. We eliminated z and we eliminated z. Why? What's the point? Look what we have. We have x and y, x and y. We now have a 2 variable system. We can solve a 2 variable system the same way we've been solving. We just need to look for something to eliminate. Does 4 go into 11? No. Does 7 go into 14? Yeah, that'll actually be the way to go. But I need them to be opposites, so I need that to be positive 14. So I need to multiply by negative 2. So now it's negative 8x, positive 14, and negative 66. Okay, I'm multiplying it by a negative because I want this to be 14, so that now when I add these together, they will cancel out. That's the whole point. Okay, we're trying to get rid of something. And I will get rid of y, and now I have 11 minus 8 is 3x, and 75 minus 66 is 9. Feeling pretty good about that. Divide by 3, x equals 3. Once you get 1, the dominoes start to fall. So we just got to work our way back up and just start plugging into equations. It doesn't matter if we use the A or the B equation. We now know x. I think this one looks easier, so I'm going to pick the A equation. But again, it doesn't matter. I know x is now 3. 12 minus 7y is 33. I will subtract 12 on both sides. Negative 7y equals 21. And then when you divide by negative 7, you get y equals negative 3. Okay, feeling good still. I've got x, I got y, I still need z. It doesn't matter which one I pick. I'll pick the one that has the smallest coefficients. So this one looks maybe it's the easiest. Doesn't really matter though. It'll work in all three. So now that I've got x and y, I'll say 4 times x minus 6 times y plus 2 times z equals 28. Again, this is the only one I don't know, but I can find it. 12. Negative 6 times negative 3 is positive 18. That'll get you. Be careful. Combine like terms. 30 plus 2z equals 28. Two-step equation. Minus 30 minus 30. 2z equals negative 2. And now, last thing, divide by 2. 2 divided by 2 is 1. A negative divided by positive is a negative 1. So as an ordered triple, 3, negative 3, negative 1. Now, did you do it right? It's a very easy thing to check, okay? Here's what I want you to do. Come up here to the top, and if you do this, you're going to get them right, and you're going to get a good grade, and you're going to have a good time. Let's plug them in. Let's see if we did it correctly. So I got my calculator, maybe. Where's my calculator? There's my calculator. I'm going to plug in this ordered triple. 4 times 3 minus 6 times negative 3 plus 2 times negative 1, okay? I know x, I know y, I know z. So I plug in x is 3, y is negative 3, z is negative 1. Just use parentheses. And if you get 28, that's a good sign. But you got to go 3 for 3. So 3 minus 5 times negative 3 plus 4 times negative 1. Plug it into the second one. I need 14. Let's go. 2 for 2. Still not convinced. 3 times 3 minus 2 times negative 3 minus 4 times negative 1. Now look, you can get 2 out of 3. It happens. It's a bummer, but it happens. 19? Let's go. So we know we did it right. Okay? You plug them in. Here's my test, Mr. Wyatt. I got a 100. Well, how would you know? Because I checked them. My calculator told me I did it right. Awesome. Do that. Why wouldn't you? Let's try another one. Get rid of. I kind of look over here. I'm like, I could get rid of z one way, but then it'd be annoying because 3 doesn't go into 4 or 2. I could do the same thing here. I could get rid of x one way. I guess I could do that, and then I could do this to get rid of x. That's one way I could go about it. I think I like y's, though, because this is 1, so I'll make like negative 3 and 3, and then 4 and negative 4. I think that's probably the easiest. It doesn't matter what you pick. Sometimes you get lucky and you solve it faster. Sometimes you go kind of a long way. But the more you do these, the more intuition you develop. I like y. I want this to be negative 3, so they cancel. So I'm going to take line 1, and I'll leave it alone. And then I'm going to multiply line 2 by negative 3. That's a 1. Okay. Negative 3 times line 2. Negative 4 times negative 3 is 12x. 1 times negative 3 is negative 3y, and negative 3 times negative 2 is positive 6z. 3 times 13 is 39, and since it's negative times a negative, it'll now be positive. Again, the reason I'm doing that, the reason I want that to be 3, didn't work, is so those cancel out, specifically negative 3. So that's why I multiplied by negative 3. Those go away. 12 minus 2 is 10x. Y's go away. 6 plus 4 is 10z. And 39 minus 29 is 10. This will be my A equation. I like that. 10, 10, 10. I'll do the same thing. I'm going to get rid of y again, but I'm going to use lines 3, and then I need that to be a positive 4, so I will multiply line 2 times 4. And this will now be negative 16x plus 4y minus 8z. 4 times 13 is 52, and it will be negative because it's a positive 4 times a negative 13. Be careful with those signs. Y's go away. 16 minus 6 is 10x. Negative 8 and negative 3 make negative 11z. And negative 52 and negative 52 and positive 44 make negative 8. That is my B equation. So we have xz. xz. Nice. That's a good sign. We got to combine those now to solve our 2-variable system. I see positive 10 and positive 10. Well, you know what? Let's just make one of those negative. So I'll just flip all the signs of line B. I'll keep this the same. And I'll make, oh, wait a minute. That was negative 10. Look, 6 minus 16, that is negative 10. So I made a sign error there, but I caught it before I got too far in here. 6 minus 16 is negative 10. Great. That makes it better. So now, when I bring this down, I don't even have to change it. They're just opposites. Whew, good catch. Now, those go away. 10 minus 11 is negative 1z, and 10 minus 8 is 2. Well, that's really a negative 1, so when you divide both sides by negative 1, you get z equals negative 2. And again, that's my 2. My z's have lines through them. They look the same. It's just too much math. All right, I got z. Now I can start working my way back up. So I will now go into x. 10 times x plus 10 times negative 2 equals 10. 10x minus 20 equals 10. I'm plugging it in right there. 10x. Add 20 to both sides. Now you have 30. Divide both sides by 10. X equals 3. All right, we got 3. We got negative 2. we just got to go back and get y. Which one looks easy? I like the one that has 1y. It just makes it work smarter, not harder, folks. All right. So now I'll do -4 times +3. I don't know why. -12 plus y plus 4 equals -13. -12 and +4 make -8. When you add 8 to both sides, last step, add 8, add 8. -13 and 8 make -5. So as an order triple, I have 3, -5, -2. That's x, y, z. X, y, z. And again, it's like, oh, Mr. Wyatt got that, so he must know what he's doing. He got it right. That's not a good way to go about things, okay? I make mistakes like everybody else. Check your work, okay? -2 times 3 plus 3 times -5 plus 4 times -2. If I plug it into the top equation, I should get -29, or 1 for 1. -4 times 3 plus -5 minus 2 times -2. I'm plugging in the middle equation. Better get -13. Let's go. 6 times x minus 4 times -5 minus 3 times -2. Plug it in. Get 44. Yes, 3 for 3. I know we did it correct. Again, check your work. It's easy to do. Her answer is no solutions. Is she correct? I don't know. Let's see. What would be a good variable to get rid of? I could probably do A pretty easily. You know what? Let's start with that. Let's see. I think I can do A right out the bat like that. This is 1 and, or this is 2 and 3. Okay, so if I do 2 and 3, I get rid of something. That's usually going to help me see something. That goes away. -6b plus 7c equals 24 minus 5 is 19. All right, no, nothing too big so far. How about we do 2 times line 1, and then I keep line 3. And the reason I'm doing that is because if I do 2 times line 1, I'll get -4, and that'll cancel out +4. So now this is -4, -2b, +4c, and -24. So -4, wait, no, that's +2. Wait, why was I flipping the signs? I shouldn't have flipped the sign. Here, minus, look. It's 2 times -2 is -4. 2 times 1 is +2. 2 times -2 is -4. There we go, okay. Be careful. Like that, there. All right, what happens here? A's go away, B's go away. Uh-oh. Uh-oh. Oh, geez. Everything went away. 0 equals 0. Wait, 0 equals 0? That's definitely true. 0 does equal 0, and I think, well, what can I plug in to break that? You can't change that from being the case. 0 always equals 0. If you get a true statement, that doesn't mean that there's, what'd she say, no solution? It doesn't mean that there's no solutions. It means that it's always true. This is an always true statement. 0 equals 0 means there are many solutions. Okay, and when you're talking about 3 dimensions, this could be, there's several ways that can happen, but sometimes we say there are infinitely many solutions. And the reason that there are, I know that is because I got a statement that is true and there are no variables. If this was no solution, I would have got something like 0 equals 14, which that is false. That would be no solution. But when you get a true statement like this, everything cancels and there's no variables, that is infinitely many solutions. These are just multiples of each other. It's the same plane. Okay, so there's infinitely many solutions here. So she was incorrect because she got, I think, the arithmetic right, but then she didn't process it correctly. That means that there's infinitely many solutions. Tricky. All right, let's set up the word problem. And these are, well, anytime it says something like this, this is where we get stuck. So I'm going to set this thing up. It says you have 17 coins in pennies, nickels, and dimes. The value of the coins is 47 cents. So we have pennies, nickels, and dimes. Let's say X is pennies, Y is nickels, and Z will be dimes. You can use other variables if you want. I'm just going to use X, Y, and Z because it's a lot. You have 17 coins. It doesn't matter what they're worth. X plus Y plus Z equals 17. You might have 17 quarters. You might have 17 pennies. Well, you don't have any quarters, never mind. Dimes or pennies, but you don't have any more coins than that. You have 17 coins, so it doesn't matter what they're worth. You have 17 coins in your pocket. The value is 47 cents, okay? Well, each penny is worth 1 cent, so I'll say 0.01x plus. A nickel is worth 0.05 cents, so that would be y, and a dime is worth 10 cents, so 0.1, however many of those there are, total up to 47 cents. If I were to solve this, I would multiply everything in this equation by 100 and move that decimal twice, okay? So it'd be 1x plus 5y plus 10z equals 47. But we don't have to solve it, and I'm using the change values right now. Last sentence is right here. This is the one that's going to get you, okay? And here's why. People are going to do this. They're going to say there are 4 times as many pennies as nickels. So you say 4 times the number of pennies equals nickels. Now let me show you why that's not true, okay? If x is pennies and y is nickels, you say, okay, I want you to plug in, you have 1 penny, you will have 4 nickels. 2 pennies, you will have 8 nickels. That's backwards. There's 4 times as many pennies as there are nickels. What you need to do is think, you need to flip this and say, this is 4y equals x. And then you can start to say, okay, if there is 1 penny, or say, let's say 1 nickel, if you plug in 1 for y, 4 times 1 gives you 4. If you plug in 2 for y, 2 times 4 gets you 8. That's what I want. Okay, so since there are more pennies, you need to multiply. Yeah, there are more pennies, you need to multiply the number of nickels by 4. And that's by far the trickiest part in this problem. If we were actually going to solve this, it's actually kind of nice because we have x and we can just kind of substitute it in and make a 2-variable system. But it doesn't ask us to solve it, so we're going to move on to the next problem. So we've got another 3-variable system. Okay, ooh, we got a lot going on. We got pictures of bikes and trikes and tandem bikes. Okay, ooh, lights going out. All right, come on, figure it out. There we go. All right, different number of bicycles. Let's call x bicycles, y will be tricycles, and z will be tandem bikes. So a tandem bike has 2 wheels, but what's weird about it is it also has 2 pedals. Okay, so the only one person steers all 3 of these things. And that's what they're talking about. It says handlebars, oh, it even tells us, bicycles have 1 handlebar, 2 pedals, and 2 wheels. Tricycles have 1 handlebar, 2 pedals, and 3 wheels. Tandem bikes have 1 handlebar, 4 pedals, and 2 wheels. So there's kind of got a, sorry, bell rang. Okay. Let's write our 3-variable system. It says, first of all, there are a different number of bicycles. There are 144 handlebars. Okay, well, each bike has 1 handlebar. So if each bike has just 1 handlebar, that's actually not too bad. We're just going to have to say x plus y plus z. There's 1 handlebar on a bike, 1 handlebar on a trike, 1 handlebar on a tandem bike, and that gets you 144 handlebars. Okay, so that means there's 144 bicycles, or 144 wheeled transport vehicles. That's our first equation. Second one has to do with pedals. So on a bicycle, let's see, bicycles have 2 pedals, so 2x. On a tricycle, there are, where's tricycles? Tricycles have 2 pedals, 2y. But on a tandem bike, there are 1, 2, 3, 4 pedals. Okay, so it's 4z equals 378. Okay, it's kind of tricky. Okay, there's 2 pedals on a bike, 2 pedals on a trike, but since there's 2 sets of 2, there are 4 pedals on a tandem bike. That was a haiku. 320 wheels. Okay, 320 wheels. Each bicycle has 2 wheels, each tricycle has 3 wheels, and each tandem bike has 2 wheels. And that adds up to 320 wheels. All right, first thing we got to do is create our system of equations, and I feel pretty good about that. Now we're going to have to solve that system, and I think I might just want to do this. Do I have this? I got space. I'll do it here. That's fine. Next thing we're going to do now is we're going to actually solve this system. So let's see if we can figure out what's a good variable to get rid of. I see that those are 2 and 2, and it wouldn't be too difficult to make that 1 and 2 or 2 and 2. So I'm going to get rid of x. I think it'll just be the easiest. Probably going to need a calculator because we got some pretty decent sized numbers here. So let's take let's label our lines 1, 2, 3. And the first one I'll do is lines 2 and 3 just because they're, where'd that go? Oh, okay. Get back down here. All right. We'll do lines 2 and 3, but I need to make something negative, so I'll make the smaller numbers negative. I'm going to make this all negative. Negative, 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 negative. If I flip the signs of all of them, that's fine. X goes away. 3 minus 2 is 1y, and 4 minus 2 is 2z, and 378 minus 320 is 58. So that's my A equation. Oh, this is negative. 2 minus, that's a negative now. 2 minus 3 is negative 1. So negative 1y, positive 2z, and then positive 58. How else can I get rid of x? Probably mess with line 1. If I make that negative 2 times line 1, now it's negative 2x. Careful. Multiply everything in line 1 by negative 2. Negative 2x, negative 2y, negative 2z equals negative 2 times 144 is 288. And I said I was going to use line, and I'm not sure it really matters. I'll just do, you know what? I'm going to go to line 3. I think line 3 might be the way to go here. 2x plus 3y, 2z equals 320. Look at that. I kind of saw it. Okay, watch what happens. X goes away and z goes away. Sometimes that freaks you out, but it's a win. You should take the win. 3 minus 2 is 1y, and then 320 minus negative 228 is 32. But we got y. We just got one of the variables. It's like, oh, that's my B equation. You can call it your B equation, but we've got one of the variables. So if two variables go away, sometimes it freaks you out, but really you should be thinking, oh, that's a win. I got one of the variables. Now I can go into my A equation and I can just plug it in. So I'm going to plug this in right here. Negative 32 plus 2z equals 58. Add 32 to both sides. 2z equals 80 and 10 make 90. So that means if you divide both sides by 2, you get z is 45. So I got two of them. Now I need to get x. I think the first equation is the best because they add up to 144. So x plus y plus z has to be 144 because we know that's how many handlebars there are. I don't know x. I know y. I know z. And I just need to combine some like terms. That's, x plus 77 equals 144. And if you subtract 144 minus 77 is 67. Okay, so we have number of bicycles, x, 67. Number of tricycles, y, 32. And the number of tandem bikes, z, is 45. And because I am so convinced this is worth your time, I'm going to check my answer. I'm going to write as an order triple just to make it easy to see. All right, come on. Did all that work. It's worth taking the 2 seconds to check it. 67 plus 32 plus 45 better be 144. Yep. 2 times 67 plus 2 times 32 plus 4 times 45. Come on, 378. Yes. 2 times 67 plus 3 times 32 plus 2 times 45. 320? 320. Let's go. Okay? I did all the work. I might as well make sure that I did it correctly. Okay? One more. This is the last one we'll do. And I'm just going to set it up. I'm not going to solve it, but I do need to at least get the setup here. And that's usually the hard part. You guys are pretty good at solving at this point. It says we have 3 variables. I'm going to type just because my handwriting is terrible. Let's see. Clothing store, restock shirts, t-shirts, polo shirts, and rugby shirts. So let's say X is t-shirts, Y is rugby shirts, and Z will be, wait, I want to put them in the right order. T-shirts, polo shirts, and then Z will be rugby shirts. Okay. So, it says you can buy, first of all, we restock 200 shirts. It doesn't matter what kind of shirts they are. X plus Y plus Z is 200. Sometimes people get hung up on the money. But that's not a money equation. There's just 200 shirts. It might be 200 t-shirts. It might be 200 rugby shirts. I don't know. But there's 200 pieces of clothing over there. What else do we know? So I've taken care of that. Sometimes it helps people to kind of, like, maybe I'll just color code it too. Look at that. Ooh, 200 shirts. That's red. Okay. What else? Money equation. T-shirts for 12, polos 24, rugby's 36. Those are usually easy. We have $6,000. So it is $12 per t-shirt. I'll do it in yellow. $12 per t-shirt plus $24 for polo shirts and $36 for rugby shirts, and they total up to $6,000. That's my yellow equation. And then the last one is the one that gets you again. You got to be careful. Twice as many rugby shirts as polo shirts. If you have twice as many rugby shirts as polo shirts, you need to take the polo shirts, which is Y, and double that. Double Y to get Z. However many polo shirts there are, you want to double it. If you have 10 polo shirts, 10 times 2 is 20 rugby shirts. So you double the smaller one. You double the polo shirts to get rugby shirts. So those are my 3 equations. I'm not going to solve this one, but you guys can check the key on Schoology. You can work through all these things. If you've taken care of your algebra math and you do your study guides, you're going to ace this test. Just make sure you hit that like and subscribe.